Alright, hello everybody, and today we're going to be having a look at how we can convert between degrees and radians. So I already introduced the idea of radians in a previous video, and remember it was defined on a circle with a radius of exactly 1 unit, so it's a unit circle. And let's consider some angle from the origin right here. Let's call this angle here theta. So in degrees, the value of this angle would just be how much of a rotation that is out of 360 degrees. But in radians, we're actually considering the arc length right here. So if we're starting right here, how much do we have to walk along our circle to make this angle right here? Okay, and remember a full revolution around the circle is exactly 2 pi, since we only have a radius of 1 right here, and we can use this fact to figure out some formulas to convert between degrees and radians. So you see we have this angle theta right here, and to convert this thing to radians, first of all, we have to figure out what proportion of 360 degrees it is. So if we take theta and divide it by 360, we're going to get some kind of fraction. So if you remember from last video, we had some person standing in the middle right here, and this value right here, this fraction, whatever happens to be, will tell us how much of a full revolution this person had to turn his head. But notice that this fraction right here also tells us how much of a full revolution another person here that's starting here has to walk around the circle. So we know a full revolution around the circle is exactly 2 pi. So we're going to multiply whatever fraction this is by the full revolution. And then in doing so, we're going to be able to find this arc length right here, which is exactly what we want. So if this angle theta right here was in degrees, all you have to do is take a fraction out of 360 and multiply it by 2 pi, which is a full revolution. And that's going to give us some kind of angle in radians, okay? And notice we can simplify this fraction a little bit because we can divide 360 by 2. So we're going to have some angle in degrees divided by 180 times pi. That's going to convert us to some angle in radians. So this is the formula to convert from degrees to radians, but how about from radians back to degrees? So what we're going to do is a similar process, but instead of taking a fraction out of 360, we're going to instead take a fraction out of 2 pi. So to convert from some angle in radians to degrees, first of all, we'll have to figure out what proportion out of the full revolution, so 2 pi it is, so we're going to divide it by 2 pi to get some kind of fraction. And if we're going to degrees, well, we know there's 360 degrees in a full revolution, so whatever proportion this is, it must be the same for degrees, so we're going to multiply this by 360 to get back to some angle in degrees, okay? And same deal as before, we can simplify things a little bit here. So we're going to get theta in radians over pi, but everything times 180. And that's going to get us to our angle in degrees. So let's compute a couple of examples now using these two formulas right here. So let's say we had 20 degrees and we wanted to convert that to radians. Well, using this formula right here, all we have to do is divide that 20 by 180, and then we're going to multiply that fraction by pi. And notice 20 into 180, that's exactly 1/9. So all in all, we're going to get pi over 9. So pi over 9 radians, that's the equivalent of 20 degrees. And as for converting from radians to degrees, let's say we had 4 pi over 5. And this angle right here is in radians. So if we want to convert this back to degrees, first of all, we have to divide by pi. And then we're going to multiply everything by 180. Notice pi and pi here can cancel out. And then we're going to have 4/5 of 180. So that just turns into, well, 1/5 of 180 is exactly 36. And then we're multiplying that by 4. So we should get 144 degrees like so. So yep, that's pretty much it for converting between degrees and radians. So yep, I'll see everyone next time.